Hello, good morning to all of you. This is the lecture on power factor improvement. This is your fourth unit, and till now we have discussed about what is power factor. There was three types of power factor: active power, reactive power, and apparent power. We also discussed what are the causes of low power factor and what are the harmful effect of low power factor. And now we will discuss about the methods by which we can improve the power factor. There are two methods mainly. This is the static capacitor method. This is the static capacitor method. The first one is, and the second one is synchronous condenser method. Today I will discuss static capacitor method. The first method will be discussed today, and the next method will be discussed in next lecture. Static capacitor method. In this, we will connect a static capacitor parallel with the loads which have low power factor. The first thing that we see that the most of the industries and power system, loads are inductive. That take lagging current, which decreases the system power factor. Maximum loads in the industry are inductive, and we have seen that the inductive element take lagging nature of power factor, and due to that power factor decreases. Now for power factor improvement purpose, what we will do: static capacitors. These static capacitors are connected in parallel with those devices which works on low power factor. We will connect a static capacitor with the devices that have low power factor. Here are some figures. The first figure is, here is a load RL that we have shown here, because we are saying that the most of the industries are of inductive nature, so we have connected a load of RL nature. Here the current that is supplied from this voltage source is IL. Now here we can see that this is the voltage uh, voltage phasor, and this is IL is the load phasor, load current. This IL is the load current. When capacitor is not connected, the this current IL makes a angle phi 1 theta 1 from the voltage. That is that this current IL lags voltage by theta 1 degrees. Now as we connected a capacitor here in parallel with this RL load, now the current that is coming from the voltage source is I. In the load current is IL, and the capacitor current is IC. We can see here, as we know that in capacitor the current leads the voltage. As this is the voltage phasor, the current phasor, that is the current in the capacitor, will be in this line, that is it leads the supply voltage. Now the net current I will be the sum of the load current IL and the capacitor current IC. Here we are seeing that this is the capacitor current IC. This was the load current, initial load current, and now the net current will be the phasor sum of this IC, phasor sum of this IC and this load current, and the net current will be this I. This I will be the net current. Now as we are seeing in this figure that this current will be just IC, because I see it here. So for phasor current, for addition, we used a parallelogram law, and the net current is like this I. Now that we can see that the angle between the voltage this and the final current, the net current is I. Now the angle becomes phi 2. This angle is phi 2. As we see that this phi 2 is less than phi 1, and power factor is cos phi 2, cos phi, cos phi, as the power factor is cos phi, cos phi 2, power factor is, as phi 2 is less than phi 1 and power factor is cos phi, so cos phi 2 will be greater than phi 1, hence the power factor gets improved. This all things are written in here. Now I can one by one I will discuss. The static capacitor provides leading current, that we have discussed, as static current will provide leading current. Leading current neutralizes the totally or approximately. It will depend upon the value of capacitance and power factor by which we want to improve. It will that much power factor will be totally or approximately neutralized by the capacitor. Leading current Leading current neutralizes totally or approximately the lagging inductive component of the load current. The power factor of the load gets improved. In the now the figures are discussed here separately. Figure 1, we have connected a single phase inductive load taking a lagging current, and the power factor is cos phi 2, that is shown here. Secondly, in figure 2, that we have connected a capacitor and has been connected in parallel with the load, and in the third figure, current IC flowing through the capacitor leads 90 degree from the supply voltage. As we can see here, that the current IC is leading 90 degree with the supply voltage V. The load current I is the vector sum of IL and IC, that is the load current, net load current I will be the vector sum of IL and IC. Now the new load the new load current I lags behind the voltage by an angle phi 2. This is phi 2 that we have made figure here also, it is phi 2, and now we can see that the phi 2 is less than phi 1. Now the power factor is cos phi 2, as phi 2 is less than phi 1, cos phi 2 will be greater than phi 1. Hence power factor gets improved. Okay, power factor gets improved as cos phi 2 is greater than phi 1, so power factor gets improved. Note, there are some note that we should understand. After power factor improvement, circuit current reduces. Circuit current got reduces. Here we can see that the initial current was IL. It is its magnitude is longer than this final current I1. This final current I is less than the initial current IL. So after power factor improvement, current gets reduced. The second note that we can see is before and after power factor improvement. Before and after power factor improvement, active component of current is same. Active component, there are two component of the net current. One is active component and reactive component. Active component is I cos phi and reactive component is I sin phi. Here we can see this current is I cos phi. This current is I cos phi, and as we can see that this length is different, this length is different, but I cos phi is same for both the power factor. So I cos phi 2, I cos phi 2 will be equal to I cos phi 2 will be equal to IL cos phi 1. So the active power component is same. in before and after power factor improvement, active component of current is same. Okay, then the next one is, as capacitor elements only reactive power component, so active power and component is same, because capacitor doesn't affect the reactive power of active power of component, so active power of component of current is same. So the net active power, that will be Vi cos phi, active power will be Vi cos phi, so active power will be same, as voltage is same and I cos phi in both the cases, that is before power factor improvement and after power factor improvement, active power is same. Active component of current of active power is same, so the active power in watts will be same in both the cases. Okay, now we will discuss the advantages of active capacitor method of power factor improvement. The first advantage is low losses, as there is no moving part in capacitor, so there is no losses in this case. uh, as there is also no moving part, therefore need low maintenance, there will be approximately no maintenance required in this case. The third one is can work in normal condition, doesn't require, it can work in normal condition. The third one is not require a foundation for installation, as a capacitor is not too much heavier, so it doesn't require uh, more foundation for installation. The next one is lightweight, so it can be easy to install, as capacitor is light in weight, it is easy to install. Okay, the next one is what are the disadvantages of this uh, capacitor methods. The first one is age of a static capacitor is less as compared to the synchronous condenser. The age of synchronous condenser is approximately 25 years and the age of a static capacitors method is only 8 to 10 years. The next one is with changing loads, we have to on off the capacitor bank, which causes switching surges on the system. As the load changes, we have to switch on the capacitor as per the requirement of the load, and we have to switch off the capacitor also as per the requirement of the load. This may change the mm, current value, and due to which uh, uh, switching surges will occur. Switching surges means if there is current uh, which can come in abrupt change in current, you can say that the what is switching surges, abrupt change in current or voltage in a system. So as we have seen that the current got changes, the magnitude of current got changes, so there will be switching surges in the system. The next one is if rated voltage increases, it may damage, as we have seen that the capacitor was connected directly to the power supply, it was parallel to the power supply. Here the capacitor was directly connected to the voltage source, and the complete voltage V is acting in the capacitor. So as the voltage increases, it may damage the capacitor. Okay, the next one is repairing is costly. uh, this was all about the static capacitor method. Here we have discussed a few things, that where the loads are inductive, and inductive loads are taking the lagging current and lagging power factor. For power factor improvement, we have to reduce the phi, this angle, and for that we have connected a capacitor in parallel with the load, and as capacitor takes the leading current, capacitor takes the leading current, so the net current, that is the I, net current I, will be equal to the phasor sum of this load current and capacitor current. The magnitude of the net current also reduces and the angle also reduces, as we know that the mm, As the angle reduces, the cos phi will increase. As the angle reduces, cos phi will be increased, and as cos phi will increase, power factor got improved. We also discussed something, some notes also, that before and after power factor improvement, the active component of current is same, so the net active power of the system will be same before and after power factor improvement. We also discussed the advantages of the static capacitor methods, and we also discussed the disadvantages of static capacitor methods. This was all about the power factor improvement by static capacitor method. In the next class we will discuss about the synchronous condenser method. We will discuss about the synchronous condenser method in the next class. Okay, all of you go through this video lecture, and if any query, any problem, then ask me. Okay, thank you. Take care and be safe at your home. Thank you.